All right, I guess we'll get started. Um, yeah, thanks for coming to my talk. I hope you're all having a really good first day of sessions and enjoying UE Fest. Um, yeah, so today we're going to talk about real-world implementation of SMPTE 2110 for ICVFX. This is more targeted towards virtual production, whether it's for film, TV, commercials, other applications of it. I'm assuming that everyone here has some knowledge of and experience with N-display already. So we'll go through a quick overview of SMPTE 2110. What is it? How it compares to previous systems and setups, how you design for it, and especially one of the features I think is kind of underutilized, the split inner frustum. And then go into some practical tips and testing, troubleshooting, things that we found out in production that I'm hoping will make other people trying to use it, give them some tips to actually put into practice. So a bit about me. My name's Julia Liu. I'm a virtual production supervisor. I specialize mostly in engine technical on-set supervision. I've done lots of jobs like tools developer, R&D, was an engine operator and on-set soup. Mostly using VR, AR, like app development, Viz, whether it's pre-Viz, tech-Viz, on-set Viz, ICVFX, of course, and virtual art department at studios like Digital Domain, DNEG, let's see, the third floor, Lux Machina, and currently Netflix. Yeah, so a bit about that. So the system that we tested all of this on was the Cinecittà Stage 18 LED volume in Rome. It's quite a big volume. It's 25 meters diameter with 8 meters tall, and it's got 5 nodes for the main wall, 1 node for the ceiling, and then a wild wall. And then we had spares as well. So it's quite high resolution, is 18K total for the width of the main wall. And we implemented this early in 2024, around like February 2024 was when we started implementing SMPTE into an existing system. And then we shot with it in production on a feature at the end of last year. So we were able to achieve an 8K inner frustum, whereas before we were more doing like a UHD sort of resolution. This was tested with dual 6000 ADAs on all of the nodes. Previously, it had been a multi-process setup. We'll go into that in a bit. And this was tested with UE54. So what is SMPTE 2110? So it's a video standard, audio and video standard, that replaces traditional analog signals like SDI for distributing video. So instead of like your SDI cables, your splitters, and your video hub and everything, this sends everything over the network. So you're sending it over switches, over network adapters, over optical fiber. So there's lots of benefits to that, and we'll go into that in a sec. But basically, it breaks down each frame into packets and then streams them across as fast as it can. And then sync is handled by the timestamp in the header of each packet. And there's a session description protocol. It's a file that gets streamed as well that describes what kind of stream you're sending. So information like the resolution, the color, like what channels are in there, all that information. So while SDI you had to specify, well, each port specifies whether it's an input or an output. SMPTE 2110 can be bidirectional, so you can send and receive on the same port, which is quite powerful. That also makes it very flexible and easy to scale. Whereas before you were kind of constrained by how many ports, say, you had available on your video matrix. Now it's just how many ports do you have on your switch and how much bandwidth do you have to add more devices. So that makes it very dynamic, and you can add, like, patching a signal isn't a physical patch anymore. You just change the multicast address, tell the receiver to look for the same address, and then that's how you connect a stream. So how is this integrated into Unreal? So Unreal uses the RiverMax implementation of SMPTE 2110, specifically SMPTE 211020, which is for uncompressed video. We're usually looking for RGB 10-bit when using it for ICVFX. You can configure it differently, but that's probably the most common case. It does require specific hardware, especially for the network adapters, so ConnectX adapters and Bluefield if you're doing PTP timing. These handle like the encoding and decoding of the video signal. And for Unreal, it does depend quite heavily on the engine version, which version of all your drivers and stuff, the SDK version to use. So that's something to be aware of, not just install the latest one because it might not work. But you can use it as in a variety of applications. Like it can be used as a media texture. You could plug it into, say, like a material and just apply material with a stream, say if you have like a TV in your scene or something. Or you could do it as an output if you wanted to render your viewport or camera and send it out. Or there's the end display use. So comparing it to previous systems, so typical previous end display systems would have done like single GPUs, probably the simplest use case. That's where everything is rendered on one GPU and sent out via the output. Then there was multi-GPU, where you had 2 GPUs or more per machine, and they were connected via SLI. So then you could have the interfrustum render on the second GPU and share it to the first, and then send it out for output. Or there was multiprocess, which is also 2 or more GPUs, but it's split into 2 different processes. So you have the first process rendering the outer frustum, and then a headless instance of Unreal rendering the inner frustum. With SMPTE 2110, you can get a lot more different configurations. So like these are all examples of like what a config might look like. You could do a single tile. You could have one node dedicated to the inner node, and it's rendering the whole inner frustum on one GPU, and then sending it out to all of the inner nodes, which then do the composite and then send it out. Or you could have it split into 2 different GPUs on one inner node, and it sends that out as 2 streams, and then the outer node composites it. Or you could expand it. We had 2 machines with 2 GPUs each, so we were able to get 4 tiles. And then you can use these in any sort of configuration. So you could have 2 GPUs rendering 2 tiles, and then 1 GPU rendering a full separate other frustum if you wanted. You don't really need to do any like repatching or anything to get it to work. You just set it into your config and set the multicast addresses. Like one thing to be aware of is that with separate processes, they do share the same CPU and memory resources. So if your content is like CPU bound or something, maybe like it wouldn't be a good idea to run multiple processes on it, but that's more an issue of optimization, I think. So previous sync and signal distribution needed physical cables from each GPU output to the processor or your video matrix. If you're doing a full SMPTE setup, that's no longer the case. It would just be done over the network, and then your processor would need to be able to receive SMPTE 2110 streams as well. We no longer need each node to render a copy of the inner frustum. So in case like cost was an issue, you could just not have a second GPU in all of your outer frustum nodes. And then you also needed tri-level sync throughout your system. So then you needed like your Genlock signal coming into like a sync card on each machine that was then daisy changed and everything. If you're doing a full setup, then PTP would handle that, and that's sent over multicast as well. You also needed to have like EDID set for all of your outputs, configure mosaic with SMPTE. That you don't really need that. Everything is running headless if it's sending a SMPTE network signal, so you don't have to do that process anymore. That kind of configures that. Another cool thing is that you can change the resolution of an output in the session because it's defined in the SDP. When you do that, it might stutter, but then it'll update and then start sending the stream, and all the nodes will read the SDP and look for that resolution instead. Like media textures and media output sources, they adapt to the resolution automatically. Yeah. One thing that is useful is that if you configure all your nodes in exactly the same way, so you can get 2 GPUs per node, then all of your nodes are interchangeable. Like you can swap an inner node with an outer frustum node. You can have spares that could stand in for any of the nodes in the system. So that's one thing to note for flexibility. So designing for SMPTE 2110. I think for a SMPTE system, there's definitely use cases where you'll see more benefits, especially for larger volumes or flexible like pop-up style or like mobile volumes or reconfigurable ones. They'll save a lot of patching video cables and stuff and be able to do that quickly. And you can also scale up much more easily. And also for full 3D content is a good application of it, especially with the split interfrustum, because you get a lot more render power. If you're doing like playback or something, you might not see as much benefit because the resolution's already baked in. And also like if you're using EXRs, the processing already handles like splitting it into tiles and streaming that in an optimized way already. So integration of 2110, it depends on whether it's like a new build, maybe you want to go all in on 2110 from the start, or if you already have an existing system with existing hardware, maybe there's some bits that are harder to replace than others. Like in our case, we didn't own the video processors, so we couldn't swap those out very easily. Yeah, so it depends on whether you want to do a full switch or like it's a new build or if you need to integrate into existing systems. And also to consider whether there's other departments, say on set or something, that will want to receive the stream as well. Like if it's for monitoring, like if you want to send the feed to Video Village or something, if they can receive a SMPTE stream or if you need to convert it to something like SDI for them. And also another thing to consider is like available slots and ports depending on your needs for your nodes. Like if you have capture cards in them, is there going to be space for like 2 GPUs and a network card and any other network adapters for other networks? If you need a sync card, yeah, we had some fun playing Tetris trying to fit everything onto one motherboard. I'll just touch on PTP a bit. I think this could probably be a talk on itself, configuring PTP and like the Grandmaster and everything. But there's lots of good videos on YouTube that talk about it. So that's Precision Time Protocol that syncs all of the video signals using multicast. It sends a sync signal and then waits for, well, it gets a reply from each of the nodes that would say like, yes, I'm in sync, and like checks for drift and everything. One thing to consider is that Bluefield 2 is reaching end of life very soon. I think they're supposed to be August, so maybe already. But Bluefield 3 is supported with Unreal and RiverMax. So bandwidth and networking. So since everything is on the network configuration is going to be very important. You need to get switches that are compatible with SMPTE 2110. And if you need to, that can support PTP as well. Especially things like flow control, IGMP, snooping, multicast settings. Like you'll want to be able to manage those and configure it to make sure that you're not seeing things like jitter and drop packets on your network. We also found that like mixing speeds on your switch doesn't work very well because it will randomly discard packets to try and reach the lowest speed. So then you'll see like tearing and all sorts of ugly artifacts if you try doing that. So definitely spend the money to get a good switch and have your transceivers match the switch speed as well. Another thing that we found was that if the network card is, say, close to the GPUs, there's a chance it could overheat, which will also cause packets to drop. So that's another thing when figuring out your motherboard layout. So how much bandwidth do you need? Generally, it's going to be like the dimensions in pixels times the bit depth times the number of channels plus the frame rate that it's sending at. When using it for ICVFX, we actually want to send faster than our show frame rate. So say we were sending at 60 FPS, that way there's enough time for the entire frame to arrive in time for it to get composited and displayed. So it was rendering at 24, but it would send at 60 hertz. So typically you'd want something that's like 100 gigabit per second or more. Another thing that's quite important is to separate your networks. If you have this blasting streams left and right, any other network traffic is kind of going to get stuck in it. So if you're doing things like remoting into your operating machine or something, it's going to make the editor very hard to use if you haven't separated out your networks. So use VLANs for sure. Separate out your tracking data, any like iPad controls, DMX. Make sure those are on separate networks. And if you're using Mellanox cards, there's 2 ports on it on the network card. So that gives you an option. Say you could have 2 SMPTE networks, or you could have one for SMPTE and then one for another use case. So in RiverMax, there's a technology called GPU Direct, which is another optimization. Instead of transferring the data from like the network card to the CPU to the GPU, it just goes straight between the network card and the GPU. So GPU Direct like handles allocating memory. It gives you a little bit of a performance boost. I think we were seeing about like 2 or 4 frames per second, which is pretty good. I mean, every frame helps. And then it is important to consider that then your GPU and network card to use this benefit need to be on the same bus. So check that they're under the same root complex. Like check the motherboard manual for the layout to see which bus everything is on. And then there's a CVAR where you can turn it off globally in the engine. Or there's tick boxes on each of the inputs, or like RiverMax sources where you can tick whether to use it or not, but that's just a quick CVAR to test. Another consideration definitely is power. So the first time we booted up the full cluster with all 5 nodes in the ceiling and the 2 inner nodes, we tripped the alarm saying that we were drawing too much power. So that's definitely something to think about. Another thing is to use system images if you can, because it's a lot of configuration on each node, and if you miss a setting on one node, you'll be hunting through all of them trying to find like which one is missing this one stupid tick box. So use system images just to make sure that all your systems are set up the same. So the split inner frustum or the tiled inner frustum, the main use for this is you get a boost in performance and then you can achieve higher resolution. So like one of the most common complaints about using ICVFX and shooting with LED is that the background looks soft and like you're kind of constrained by the performance of your machine and how high of a resolution it can render before you start dropping frames and start seeing like stutters. So splitting the inner frustum across GPUs, you get a lot more render power. Like our previous solution to this on those about to die was just to use the entire wall as a frustum basically, and we tracked the outer frustum, which then gave us high resolution, but then you lose things like depth of field, everything is on like the same focus plane, and you can't easily turn on like make the frustum blue or turn on chroma. You'd have to like put something there, turn the frustum back on, and then switch it to chroma. And you also lose some color correction abilities. Like one thing that some DPs do is they'll grade certain sections of the wall, and they'll like use that to grade their shadows or something. But if your entire wall is your frustum, you can't really easily switch an entire section of it to a different color. So splitting the inner frustum takes care of like those issues, and it gives us more render power. So like, how do we split it? I think the most common configuration for like if you're doing 4 tiles is just to split it in a cross, which makes sense. But you can also split it in different directions if, say, you're seeing artifacts, like depending on your camera move, you could have it go in a different direction. So like if you're doing a horizontal split, you can fix things that are issues on vertical seams, especially if your camera's panning. So then it's because it's moving along the same direction of the seams, you won't see those as prominently. Or like the same for vertical split for horizontal seams. And then like operating a SMPTE 2110 cluster for like engine TDs and operators is generally going to be the same as operating another end display setup. There are some things to keep in mind with like setting resolution and overscan and such. So you can set your custom resolution on the ICVFX camera component in the custom resolution section. And then you can increase the screen percentage to do a multiplier on it. And then one thing to note is that like if you change the resolution or something during the session, you are going to get like a stutter while it updates. So best not to do it in the middle of a take. But you can change things like the overscan if you turn adapt resolution off. So if you're like in the middle of a take and you see the camera's about to go out of the frustum, you can increase the overscan a bit and that will be fine. So building content for the split inner frustum, I think most of these things are best practice for end display anyway. Like if you were, say, doing a multi-process or multi-GPU setup, you would still have issues with like the nodes rendering non-deterministically or something. So these things are still best practice. But with the split inner frustum, you probably want to be a bit more careful with it. So big one is always no screen space effects. Things like bloom, vignette, screen space fog, SSAO. SSAO you might be able to get away with if you have a really tiny radius, but yeah, best not to use it. Instead, try to look for things that are using like rolled camera view or projection clip space instead. So you could still do like post-process and stuff, just try to use those spaces instead of screen space. Another thing to use is overscan. It helps blend the seams between each of the tiles because there'll be a hard line where the seam is. There isn't like a feather or anything in there now. So you can overscan a little bit to help fix like, especially things like culling and like lighting artifacts. It'll help those blend a little bit. The cool thing is that it only overscans on the the interior seams, so it's not like overscanning outside the frustum and like you're losing resolution there. So it's just where the overlaps are. Niagara effects, of course, they should be deterministic. If, say, you're using PCG or something, if you've cached it, it's probably fine, but if it's like regenerating PCG, you probably want that to be deterministic as well. And to set your sort priorities on things like post-process and translucent materials, especially big things like, say, you have volumetrics that are like fog or something, and you have multiple layers of fog, you want to set your priority so it knows which one to draw on top and like that order is consistent. Otherwise, you'll see some mismatches between the tiles. So blueprinting for split interfrustum, I think it's usually the ones that are driven by time that are most likely to have seams in them, where some of them might be like slightly off, especially if it's like doing something on the transform, like the translation or rotation or something. Some things might be easier to do using sequencer if you're trying to do something like very precise timing. But if it's something that's just like in the background, just something moving to give it a bit of life, you could do it in a blueprint. I don't recommend using timelines. They tend to be quite heavy. They're also quite hard to control sometimes. So try to avoid timeline nodes whenever you can. The way I usually go about making blueprints for the system is to use the tickable actor class as a base. Usually the first one, the one that's highlighted, the VP viewport tickable actor base, that one works both in editor and on the wall, so you can see it updating in your editor on tick as well. Like generally, you don't want to have too many actors that are ticking, so you could have one controller that's using this base class updating like a bunch of instances of your actors in the scene. And it's pretty easy to use. Like it just exposes the event editor tick, and then you can connect that like you would like with your regular tick event. Another thing that's helpful is to use the timecode node. You can feed that either into an actor with a blueprint, or you can like feed it into your materials. So then that can drive like a material or actor using time because it's timecode. And if you have timecode across your system, all of the nodes will be using the same timecode to update with. You can also use the delta time because you're going to have genlock and sync and all that. So the delta time will always be the time of one frame. So in case you do have cases where you're updating a blueprint and then you see it mismatches across nodes, there are some components that you can use on your actor, the sync components that will sync over the end display cluster. So you can add those to your blueprint. And also using random values is a big one that can sometimes be non-deterministic. So use the random stream that you can set a seed on it. You can set a seed value for it to start generating the numbers from. And you have all your different data types like float, int, whatever you want. So use those instead. So like we were using Lumen and ray tracing, nanite, all that. Lumen particularly, like some of the parts of it are temporal, so like you'll get some seams as it's updating. So one way to fix this is to increase the Lumen update speed and the final gather update speed. So that will make Lumen update the scene faster. but it doesn't have a cost on performance. So adjust it as high as you can get without dropping frames. And another big one for artists is that you need to disable screen traces because it's a screen space effect. It does make your reflections look very pretty, but it causes lots of seams in a split in a frustum. So it's best to build the content with that in mind, not to use that feature. So upscaling and denoising, again, these are temporal. So if you're using like TSR or something, you may see like a trail as like the frustum moves. I think you could see it slightly on here. You can see as it passes across like that door, you see like a shadow moving across. That's where the theme is. So you can change your TSR settings. You can decrease like the time or like change the number of samples to try and adjust for that seam. You can also tune things like max roughness to trace or like max ray intensity, which is adjust like how bright or like especially for noise, you'll see like a trail of like sparkles when the frustum moves across sometimes. So if you decrease that, it won't be as reflective or shiny. So you might be able to fix some of the seams that way. You can also use DLSS and DLSSR to help with denoising and upscaling as well. We use those in production. Those also give you an additional performance boost because it reduces the screen percentage that you're rendering. So like you can render at say like 80% screen percentage and then let DLSS do the upresing on it. So another useful thing for artists, especially if they don't have a cluster to test the content on beforehand, is to preview it in the editor. You can turn on the preview editor on the actor directly and you'll see it in your viewport updating. It can be a bit heavy on performance, so previewing the cluster, you won't be able to test like performance and optimization as much, but you can check for seams and that kind of thing. You can also launch the editor or launch NDisplay directly from the editor using the NDisplay quick launch feature. That basically lets you launch as if you were launching the node on your machine. So again, it won't be performant, but you can see if there's going to be seams or other artifacts. And the thing is still, even though we have a lot more render power, you still need to optimize. Like I think the goal of having more render power is to be able to achieve more photorealism, add more detail. So you still want to have optimized content. It's not like you could just throw anything at it and expect it to work. So use insights and profiling to get better performance beforehand. You probably want to have like about 10 FPS overhead. So like then when you get to shoot, you have some room to adjust things or increase like your overscan or resolution a little bit. But it's only going to run as fast as the slowest node. So if you have one particular section of your scene that's more problematic, the whole scene is going to run to as fast as it can render that. So that's something to keep in mind. So here's a bunch of CVARs that we used. Yeah. Yeah, lots of CVARs. There's also like RiverMax CVARs as well. You probably don't need to touch those that much. Most of it you can handle in like the NDisplay config settings. But these are some handy ones just to use. And then testing and troubleshooting. So definitely use Wireshark. Check for any drop packets. You can use analyzers like Fabrics to check the signal or generate a SMPTE stream if you want to test outside of Unreal, just to check your network. definitely monitor the network usage. You could just use the one in Task Manager, that was fine, just to see how much is being sent out. And the big one is definitely check the logs, because it's pretty hard to diagnose things on a cluster, especially if you have a lot of nodes. You have to kind of go through all of them and see which one has the issue. So I think one way to approach it is just try to isolate the issue. So maybe first try testing end to end. You can test as a media source and output, just from two editors as a sender and receiver. You can also test on the same node, but it's probably best to test on two separate ones. So here's some like setup of like setting up the media output, setting up the media source, and then if it's working, it should be like that last picture where you'll see the viewport or like the camera view in your both your media sender and receiver. I think one of the most frustrating issues is when you get a black frustum or a black cluster. It usually means that the config or rivermax wasn't set up correctly. So check the log. If you see something like that bit of the output log up there, you'll see like the error. It's not very descriptive error message, so it says it wasn't installed or like not initialized. It was actually the wrong version of the SDK, so go back and double check that. Make sure that you follow the steps. I'll put a link to the Unreal SMPTE setup guide that has a lot of steps for like any environment variables and things to make sure they're set. Also check that your multicast addresses and stuff are set up correctly. In 5.6, it actually does a lot of that config for you. So it'll make a unique multicast address for each of the streams and connect which ones are inputs and outputs for you. But something to double check. And also another one is that if it's not using the right timing source, it'll also come out black. So double check that you have it set to PDP if you're using it or set to system time if you're not. So that bottom log in the white box is what you want to see, is like the stream started successfully and has all the information about resolution and color and all that. So that's what you want to get. Stuttering or tearing. This one is if your rivermax setup is correct, but maybe there's an issue on the network. So we saw things like that where it starts shaking as it's moving across. Or this one on the bottom, like that ball was just meant to go back and forth. So that was actually when we had the mixed speeds on the switch, and we were seeing like the dropped packets from the mixed speeds. So if you're getting something like that, it might be worth checking your network and making sure that that's set up all right. You'll also see in the log when it's dropping packets as well. Another thing to double check is probably that sync is set up correctly. Say if you're using tri-level or PTP sync. There's an end-display test pattern that's built into the engine that's really handy. It does a moving pattern, so you can just check that that's you're not getting seams across or they're not traveling at different speeds or something. It should go across the entire cluster. So that one you have to add an actor into your scene and then set the CVAR. That's the one that I usually use for testing. You can also troubleshoot outside of Unreal. On the rivermax SDK GitHub, they have some sample apps that you can compile. And there's like a simple sender receiver in there. So you can use that to check if like it's just an issue with like your SMPTE install or something. But this could be another way to help narrow down the issue. And another big one for like jittering and other artifacts is to check your Windows settings. on the GitHub, there's actually a script that will go through and set all your Windows settings for you, which is pretty handy. It's just a little PowerShell script, so you can download it from the GitHub and run it, and it'll configure all the things that you don't want to have, like it'll disable like flow control and the large page support and all that stuff. So all the settings that RiverMax wants for streaming. And then once you get end-to-end working, troubleshooting on the cluster, it's probably better to start from fewer nodes and then work your way up. So in Switchboard, you can just like disable a node or something. Just start with, say, 2 nodes, like 1 inner, 1 outer, and then work your way up until you get to the full cluster. It just helps to narrow down whether it's like an issue with the setup or if it's one node specifically. And you can just override the IP addresses in Switchboard, so you could swap them around as like, is this node working, but that one's not, or something like that. You can also receive the inner frustum stream on any machine. So like another way I was testing was just to like start up the cluster and then try and receive the inner node stream onto like a media source. So there's lots of different ways that you can test it. So looking ahead, I think that SMPTE 2110 is starting to get more and more adopted into like film, TV. Broadcast is already using it. They've been doing so for a while, but as more of the hardware starts supporting SMPTE 2110 and PTP, we'll see more of it get used. We'll have lots of different uses for it, like not just for end display and for the cluster, but also maybe for things like setting up monitoring, like doing multi-views and stitching and stuff. Or say if you're doing like a simulcam setup, you could use that to send out your Unreal feed. And maybe we could use it the other direction as well, receiving camera streams or camera feeds from like, say, the show camera, or if you have witness cams or whatever, getting those into the engine from over SMPTE. So here's some links to some really good resources, especially the Unreal Guide. It takes you through a lot of the setup, especially like on Windows, configuring your drivers and all that stuff. So definitely have a look at that. The RiverMax GitHub, as I said, has lots of resources for testing and the script for tuning as well. And then there's a more detailed RiverMax tuning guide that goes through like why each of the settings are important and why to use it. So that's also worth looking at. So yeah. Thanks for listening to me ramble about SMPTE. I do want to thank Epic and the virtual production team, especially Alex and Ben. They helped out a lot while we were testing out the system and troubleshooting and sending us fixes and such. And the Dimension team, especially systems, IT, on-set content, they helped out with installing the system, figuring out how to build content for it, making content for a show, operating it. So definitely it was a big group effort to do this. And Cinecittà Studios for letting us test on their volume and all the long hours to be like, can I just have another half hour of the wall, please? So I just want to thank them. And yeah, I guess we might have a few minutes for some Q&A, but I'll be around and feel free to ping me if you have any questions. Yeah.